Hello viewers, welcome to my channel. In this video we are going to discuss about the basic concept of physics. If you want to some lecture in Urdu, go in the description, click on a link and enjoy the lecture. In this lecture, we are going to discuss about this whole lecture delivered in English language. In this lecture, we are going to discuss about the physical word. See, this is a students. This is a physical word. Now let's we continue. When we enter, see, this is a physical word. This is a whole is a physical word. Once we enter in a physical word, firstly we meet with a science. Once we enter in a physical word, we meet with a science that describe the what is science. Actually, this is a science. What is science? Actually, what is science? The whole physical word is based on science. What is science? It is a systemic, we call it organized or systemic knowledge of the physical or material world gained through observation and experimentation. It means what? Systemic knowledge, organized pattern. How we can say that? It is a systemic knowledge. It is a systemic pattern. How we call it? See, let us consider science is based on, if it may be bio, it may be chemistry, it may be physics, it may be geology. It means any type of a science based on what? Organized knowledge. Systemic organized knowledge of the physical or material world gained through observation and experimentation. This is a whole about what? A science. What is science? A systemic knowledge of the physical or material world gained through observation and experimentation. How we can say that it is organized knowledge? How we can say that? We can say that, see, suppose any kind of a discovery based on what? Hypothesis, then prediction. It may be prediction, hypothesis, prediction. It may be then after that theory, then law, then proved by the scientist. This is an organized pattern for a science. Organized pattern for a science. So what is science? A science, systemic. What? A systemic knowledge of the, it is a systemic knowledge of the physical or material world gained through observation and experimentation. It is a systemic knowledge of the science. Now let's we continue on next categories of a science. Categories of a science. Science categorized into two categories. It means we have a two type of a science. In this world, the science categorized into two categories. How many categories of a science? The science categorized into two categories. Number one is a real science. It's a real science. Number one is a real science. Number two is a pseudoscience. What is the difference between real and pseudoscience? Real science bases on theory where reality doesn't change. What is real science? It is a science where reality doesn't change. It means the reality doesn't change. This is called what? real science. How we can say that? See, Newton laws are same at everywhere. In a Pakistan, in America, in India, in any country, all Newton laws are same. See, I am throwing a body here. If I throw a body in a Pakistan, it goes downward. In any country, we are discussing about the earth, not a vacuum. When a body throwing upward or downward, it means what? It goes down. It means the reality doesn't change. In a real science, reality doesn't change. It is the basis on a theory. It is the basis on a theory where reality doesn't change. Now next is another example of real science is physical science and biological science. There are two categories of real science, physical science and biological science. We will discuss in this lecture in the next. Another is a pseudoscience. Basis on a paradigm where reality change. In this condition, in this science, reality change. Like we are going to example is a social science. We call it a social science what? Social science. In this science, like economy, like politics, like a political science, like economy, these sciences are changed. Economy for a Pakistan is a different, economy for a different country is a different, like a political system in the Pakistan is a different. It means in this science the reality is changed, but in a real science the reality doesn't change. In this type of a science, reality doesn't change, but in this type of a science, reality change. So science categorized into two categories. Okay, then real science categorized into two categories. Number one is the physical science and other is biological science. Well, firstly, we are going to discuss about the physical science. In a simple word, we call it a physical science, study about non-living things. Study about non-living things. Study about non-living things. In a simple word, we call it study about non-living things. Okay, physical science, this is a basic definition, mostly in a cheapest book. These definitions about non-living things. This is a very simple definition. Okay, the main definition we are going to discuss about the physical science. The physical sciences are branches of a science, such as like in this branch we are going to discuss about the physics. We are going to discuss about the chemistry. We are going to discuss about the geology and the concern with the natural forces. These sciences concerned with the natural forces and things that don't have life. Things that don't have a life. The same definition is study about non-living things. Study about non-living things. It is the basic things is study about non-living things. Are concerned with the natural forces and the things that don't have study about. This is the basic definition. Study about non-living things. This is a basic definition of physical science. The next one is a biological science. We are going to discuss about the biological science. Biological science, in a simple word, we call it study about living things. Study about living things. In a basic, we are going to discuss about the biological science. The biological science is a study about living things. The science of life or living. We call it the science of life or living matter in all its forms and phenomena, especially with the reference to the origin, how to grow, how to reproduce, what is the structure, and what is the behavior of a living organism. You will learn in biology if you are a medical student. These two branches are concerned with real science. These two branches are concerned with the real science. The next one is the very pseudoscience. It's a social science. We call it social science. A group of academic discipline. What? Academic discipline dedicated to examine what society. It is examined society. This branch of science study how people interact. In this science, we will discuss, you will learn in social science that how to interact with the person, with each other, how to behave, how to develop as a culture, how to influence, like example, anthropology, economics, political science, sociology, and we call it as psychology. So these are concerned with the pseudoscience, and here we are going to discuss about the physics, not other type of science. That's why we are only concerned with the physical science. Okay. Now let's return our main and important topic. That is the most important topic is what is physics. This is the main and important topic. What is physics? We are going to discuss about what is physics. Now let's start our definition of physics. Physics is a natural science. In a simple word, we call it physics is a concern with the physical science. That's why we are going to. Physics is a branch of physical science. Physics is a branch of physical science that involves the study about what? Study about matter and energy and interaction between them. So what's the physics? Is the natural sciences that involve the study of matter and its motion through space and time, along with the related concept such as energy and force. In a simple word, we call it what is physics. It is the branch of physical science in which we are going to study about the matter and energy and how matter and energy interact to each other. This is the main and basic definition of physics. Okay, conducted in order to understand how the universe behaves from the largest object to the smallest. So this is all about the basic definition of physics. Now further, physics categorized into physics categorized into two main categories. The whole physics is divided into two categories. Number one is a classical physics and other one is a modern physics. We are going to discuss about the classical and modern physics. Classical physics, it is also known as a Newtonian physics. Classical physics, it is also known as a Newtonian physics, it means, and it is also known as Einstein physics. Modern physics also known as Einstein physics. Classical physics before 19th century, point be noted, before 19th century, and in modern physics, it is the basis on after 19th century. It means before 19th century, considered as a classical physics, and after the 19th century, it is considered as a modern physics. Point to be noted, based on Newton's laws of motion, classical physics. It is classical physics, Newton first, second, third laws of motion. These are classical physics based on Newton's laws of motion. And modern physics are based on theory of relativity. Theory of relativity. In classical physics, study about one and two dimension. What we call it? What is it? One and two. One dimension means when a body moving in an x direction, this, when a body moves without coordinate system in a y direction, when a body moves without a coordinate system in a z direction, it's a z, we call it actually it's a z direction. So this is the study about one dimension. What is the two dimension? It means this is the x, this is the y, and this is the origin point, and body rotates in a xy plane. It means a two-dimensional motion. When a body moves in a just in a x, just in a y, just in a z, it means what? This is the one dimension and this is the two dimension. Okay, next, father of classical physics is Sir Isaac Newton. Father of classical physics considered as Sir Isaac Newton, and father of modern physics is Sir Albert Einstein. Okay, in a modern physics, study about 3 and 4 dimension. In modern physics, we have 3 dimension: x, y, and z. This is x, this is y, this is z. It means at the time of, it means a 3-time motion. It means as an x and y and z. We will discuss in our next lecture in detail. Okay, mechanics, optics, acoustics, thermodynamics, electrostatics, electromagnetism, electronics. These are branches of physics. Okay, atomic, nuclear, plasma, solid state, astronomy, these are considered as branches of modern physics. Okay, now classical physics are macroscopic. Macro means a large. Macro means a large observation of matter, large matter, and focus on a microscopic observation. In a modern physics, focus on a more microscopic, and in this condition, observing it's a microscopic observation. We continue next. This is a physical word. This is a physics. Physics is totally composed of physical quantities. Physics is totally composed of physical quantities. Physical quantities. Physics is based on physical quantities. What is the physical quantities? What is the definition of physical quantities? Physical quantities is a quantity that can be measured, easily measured. It means we can measure easily. This is what? This is the definition of physical quantities. Scientists observe that the whole physical world is composed of physical quantities, and what is the definition of generally physical quantities? Those quantities which can be measured, physical quantities that can be measured. Okay. Now, the whole physical quantities is divided into base quantities and derived quantities. What are the base quantities? These are fundamental quantities having their own dimensions. Like example, we're taking a length, a mass, a time, a electric current, etc. And derived quantities these are quantities, or we call it the quantities which can derive from a base or fundamental quantities. It means what? Okay, we continue. Base quantities. What are the base quantities? 3 quantities cannot be derived from other physical quantities: a length, a mass, a time. A length, a mass, a time. What is the unit of length is a meter. What is the unit of mass is a kilogram. What is the unit of time is a second. See, these are length, mass, and time. These are base quantities. Base quantities, and these quantities cannot be derived from other physical quantities. What we call it? Not derived from other quantities. But after researching and consider the whole physical world is composed of 7 fundamental quantities. These 7 fundamental quantities cannot be derived. Okay, our mass, length, time, current, temperature, amount of substance, luminous intensity. The mass, its mass is an m, its unit is a kilogram, its symbol is a kg, its another is a length, its a representation of an m, its unit is a meter, and it's an m. Another is a time is represented with a t, its unit is a second, and its will represent SEC. What's the representation? SEC. Another is a current, it's a representation of I, and its unit is an ampere, and representation of A. Another is a temperature, it's a T, capital T, it's a SI unit is a Kelvin, and it's represented the K. Amount of substance, what we call it amount of substance, it's the representation of as a TL, and its unit is a mole, and we call it MOL. Another is luminous intensity, its sign is LI, and its unit is a kind. Another, we are going to discuss about the derived quantities. These quantities can be derived from fundamental quantities like area is a length into breadth, it's a meter square, volume is equal to length, breadth and height, frequency is a 1 upon T, its a density is a mass upon volume, is a velocity or speed displacement upon time. Speed is equal to distance upon time. It's an acceleration, a change in velocity per unit time. It's a meter per second square. It's a hertz or per second. It's a kilogram per meter cube. It's a meter per second. It's a meter per second square. Acceleration meter per second square. Pressure force, it's a Newton upon meter square is equal to Pascal. Work energy is equal to Joule. We call it kilogram meter square per second square. Another quantity is electric and other potential difference, and many more, volt, coulomb, and ohm resistance. So these quantities, many quantities, we will discuss in topic by topic in a detail. But here we are only going to discuss about what? Just a basic description. The whole physical world is divided into 2 types of quantities, fundamental and derived quantities. Now let's return about the systems of units. Now we are going to discuss about the systems of unit. Number 1, FPS system. F means foot is a unit of length, pound is a unit of mass, but some countries consider it is a unit of force, and time is a second. This is a very old system. And a CGS system, centimeter gram second system. And there is an MKS system, meter kilogram second system in use. This is in use, used for only scientists. This is a very old system. MKPS system, meter kilogram per second, not in use. MKFS system, kilogram force second. This is also not in use. MTS system, meter turn second, not in use. QES system, allowing gram second. This is mostly used government. This is mostly used for government, but this is not in a use. NKS, CGS, FPS. Nowadays a new system, it's a SI system. It's a system of international system. Why we create a system of international? Because some countries use CGS system, some countries use FPS system, some countries use MKS system. That's why the pilots, other like transport, like economy development, like trading, it means in many difficulties for a person. That's why scientists make a main system, we call it what? System of international. What type of system? System of international. Okay, let's we continue length conversion. Our length conversion, length kilometer be meter, meter be centimeter, centimeter be meter. How we convert it? When we convert from kilometer to meter, it may be multiplied with 1,000. When convert from meter to centimeter, it may be multiplied with 100. And when we convert into centimeter to millimeter, it may be multiplied with 10. Same larger to smaller, larger to smaller, larger to smaller multiplied, smaller to larger divided. When we convert into millimeter to centimeter, divided with 10. When we convert centimeter to millimeter, divided with 100. And when we convert into meter to kilometer, divided with 1,000. Taking one example, how many meters in a 10 kilometer? 10 kilometer, how many meters in a 10 kilometer? 10 kilometer, let's we continue. 10 kilometer is equal to 10 into 1,000. So 10 kilometer is equal to 10 is power 4 meter. So 10 kilometer consists of 10 is power 4 meter. Let's another continue. Mile to yard, yard to foot, foot to inch, inch to foot, foot to yard, yard to mile. When we convert mile to yard, multiply with 1760. When we convert yard to foot, multiply with 3. When we convert foot to inches, multiply with 12. Okay, another, and when we convert inch to foot, it will be divided with 12. When we convert foot to yard, it can be divided with 3. When we convert yard to mile, it can be divided with 1760. So this is the length conversion. This is the length conversion. Now let's we turn about the mass conversion. How we convert the mass? This is the mass conversion. How we convert the mass? Converting of mass, metric. Okay, metric mass. Kilogram to gram, gram to centigram, centigram to milligram. Kilogram to gram, gram to centigram, centigram to milligram. Okay, when we convert kilogram into gram, multiply with 1,000. When we convert gram to centigram, multiply with 100. When we convert kilogram to milligram, multiply with 10. When we convert milligram to centigram, divided with 100. Centigram to gram, divided with 10 and 100. And when we convert gram to kilogram, divided with 1,000. This is the mass conversion. This is the mass conversion. How we convert mass from kilogram to gram, gram to centigram, centigram to milligram, milligram to centigram, centigram to gram, gram to kilogram. This is the mass conversion. And next we turn the time conversion. A time converter. 1 minute is equal to 60 seconds. 1 hour equal to 60 minutes. 1 day equal to 24 hours. 1 week equal to 7 days. 1 month is equal to about 4 weeks. 1 year equal to 52 weeks. 1 year equal to 12 months. 1 year equal to 365 days. 1 leap year is equal to 366 days. 1 decade is equal to 10 years. 1 century is equal to 100 years. And 1 millennium is equal to 1000. How we convert? See, week to days, days to hours, hours to minutes, minutes to second. See, week to days multiply with a 7, days to hours multiply with a 24, hours to minutes multiply with a 60, minutes to second multiply with a 60. Now second to minutes divided with a 60, minutes to hour divided with a 60, hours into days divided with a 24, and days in a week divided with a 7. Now next, how we convert it? 1 week 7 days, 1 day is 24 hours, 1 hour 60 minutes, 1 minute 60 seconds. See, 4 hours is equal to how many minutes? Big to small. We multiplied small to big. We divided. Point to be noted is, dear viewers, a point to be noted. Big to small. Small we multiply. Small to big we divided. In a conversion, in a length, in a mass, in a time, in any conversion, a big to small we can multiply it, small to big we can divide it. Okay, the next, and factors, prefixes in a physics. In a prefixes a deca 10 plus, positive prefixes deca 1, 10 is power 1, deca, hecto, kilo, mega, giga, tera, petra, exa, zeta, iota, and 10 is power 1, 2, 3, 6, 9, 12, 15, 18, 21, 24. This is positive prefixes. Deca 10 is power 1, hecto 10 is power 2, kilo 10 is power 3, mega 10 is power 6, giga 10 is power 9, tera 10 is power 12, and petra 10 is power 15, exa 10 is power 18, zeta 10 is power 21, and iota 10 is power 24. Negative prefixes, deci 10 is power minus 1, centi 10 is power minus 2, milli 10 is power minus 3, micro 10 is power minus 6, nano 10 is power minus 9, pico 10 is power minus 12, femto 10 is power minus 15, atto 10 is power minus 18, zepto 10 is power minus 21, yocto 10 is power minus 24. Okay, so let's we are going to continue another condition we are going to continue. Okay, whole physical world basis on two quantities, base or fundamental or derived. Other quantities are supplementary quantities. Supplementary quantities are two quantities. One is a plane angle, we represent with a theta, its unit is a radian, and other is we call it a solid angle. It's a phi, its unit is stray radian. These are two supplementary quantities. It means a whole physical world is composed of base, derived and supplementary quantities. Okay, next we continue dimension. It's a dimension is another topic. Dimension, what is dimension? Show the nature of physical quantities. show the nature of physical quantities. Show the nature of physical quantities. It means 7 fundamental quantities. Number 1, length, its dimension. The dimension of a length is L, it's a symbolic representation. Number 2 is a mass, its dimension is capital M. It's another quantity is a time, its dimension is a capital T. Another quantity is a current, electric current, its dimension is A, ampere. Another quantity is a temperature. Temperature has a 2 dimension. Some are a theta and some are a capital K. Some scientists believe that its dimension is a theta, and some scientists believe in that the temperature dimension is a K. And another quantity is the amount of substance. The dimension of amount of substance is capital N. Dimension of a luminous intensity. The dimension of a luminous intensity is J. The dimension of luminous. So 4 categories of dimension. How many categories? 4 categories. 4 categories of dimension. 4 categories. Number 1, variable. Variable. Dimension. Physical quantities. Variable, dimension, physical quantities. Those quantities having variable value, but it has a dimension. Like an area, taking 1, 2 example. Area is equal to length into breadth. Area is equal to length is L into L is equal to L square. Like taking another example, volume. Taking another example, volume is equal to length into breadth into height. Volume is equal to length is L into L into L. Volume is equal to L cube. This is the first category. Area may be variable, volume may be variable, velocity may be variable, acceleration may be variable, force may be variable, pressure may be variable, and work may be variable, energy may be variable, power may be variable, momentum may be variable, torque may be variable. These all are concerned with the first category of a dimension analysis of variable dimension physical quantities. Now next, another category is constant. Another category, constant dimension physical quantities. Dimension physical quantities. Like a gravitational constant is equal to F_r square upon m square. F dimension ml over t square into L square into, it's a meter, it's a L, it's a mass, it's a m square. This is m cancels, so m inverse L cube t inverse square. Like a spring constant, like a Coulomb constant, many constant having dimension, it is categorized into second category. Number third one is a dimensionless, variable dimensionless. Variable dimensionless. It means those quantities are variable. It may be angle, it may be plane angle, it may be solid angle, it may be plane angle, it may be solid angle, it may be plane angle, it may be solid angle, and these 2 categories and categorized in what? And these are plane, but it has no dimension. This is a third category. Number 4 category, constant dimensionless physical quantities. Constant dimensionless physical quantities. Physical quantities. Number 1, like a pi, it's a pi is equal to 2 or 3.14, 22 divided by 7. About what? This is all about It's a dimensional variable physical quantities. This is the whole about the dimension. Now let's return in a significant figure. The last topic of this lecture, significant figure. What it means, significant figure. What it means, significant figure, the reliable digits which showing certainty, availability in a number. It means showing a certainty, availability. Okay, let's return the rules of significant figure or counting of a significant figure. Now let's return about all the non-zero digits are significant figure. It means those digits 2, 7, 3, 8. There is no any zero, all of the digits are non-zero. That's why we consider these all are what? All are significant figure. Let's we check in another condition like 1, 4, 3, 2, 6, 8. How many significant figure? 2, 4, 6. How many significant figure? 6 significant figure. Now let's we turn the another rule. All the zeros between two non-zero digits, no matter where the decimal point is, no matter, but zeros between non-zeros. First rule, all non-zeros means in the digits there is a no zero. But another case, 1, 4, 0, 0, 6, 8. How many significant figure? All are considered as significant digits. How many significant? 1, 2, 3, 4, 5, 6. How many? 6 significant digits. Now let's we continue another condition. If the measurement of a number is less than, zeros at the right of the decimal point. Take an example. 0.00807. How many significant figure? First 3 zeros. These 3 zeros are not a significant figure. How many significant figure? Only 3. Like a 0.00807. How many significant figure? 807. How many? 3 significant figure. Another rule is let us another take an example. 0.008106. How many significant figure? 4 significant figure. Let's turn to another rule. The terminal are trailing zeros. Trailing zeros in a number without a decimal point are not trailing zeros. 100. These are trailing zeros. 1000. These are trailing zeros. 10,000. These are trailing zeros, and these are digits are not considered as a significant digits. Let us another without decimal. If the trailing zeros in a number in a decimal point, let us consider 3.800. How many significant? All are considered as a significant figure. All are considered as a significant figure. Like 1.000. How many significant figure? In this 4 significant figure. In this condition 4 significant figure. In this condition, without decimal, all trailing are not significant figure. But once a point, a decimal 3.800, 4.8600, 9.800, these are all considered as a significant digits, significant figure. Another condition, a choice of a change of a unit doesn't change the number of significant digits in a figure in a measurement. All the exponent form, let us consider exponent form. What we consider it exponent form. What it mean exponent. Like a 10 is power 6, 10 is power 9, 10 is power 21, 10 is power 11. These are not significant figure. Hope viewers you enjoy the lecture. If you enjoy, press the like button. If you are new on my channel, please subscribe, press the bell icon. You will get all the notification of wonderful videos. In next lecture, we will discuss scalar vector. God bless you. Thank you.